Solving some systems today. They will be on our test to do it like this. So the first one's solved by graphing. Let's do that bad boy. I love that y is all by itself. So on my first guy, I got a y-intercept of 3. So I'm going to start up here. And then remember, it's rise over run. So we'll go down 5. 1, 2, 3, 4, 5. To the right 3. 1, 2, 3. I'm going to put at least 4 dots. 3, 4, 5. 1, 2, 3. And then got to go up the other one, up 5, and to the left 3. And then I'll take my straight edge and connect those bad boys together. And what I'm looking for is when I graph that other line is where they intersect. It's totally possible for them to not intersect. It's also possible for them to be right on top of each other. So -3, rising 1, running 3. Boom! That's my winner right there. Because what I'm looking for is where I get like a purple dot on top of a red dot, and I got that to happen. Please finish the question though, so if you want to just take the straight edge and connect those together now, or if you want to plot another point. But I do ask that you continue to finish graphing the other line, and we're looking for where those lines intersect each other at. And that is kind of the most missed thing about questions like this is we all graph it very well. It's just like writing that ordered pair. Sometimes we get it backwards, you know. So what is this ordered pair? X first, Y second. Where would that be at? 3, -2. Watch out, because sometimes people just put 3, 2 on accident. It's like, oh, duh, of course it's -2, you know. So just watch yourself on that. When you type it into the homework program, you will need parentheses unless they have them on the outside of the answer box already. So pay attention to the parentheses versus the parentheses, not needing it. And of course you need comma. Then you've learned how to solve it on your graphing calculator. So let's graph this dude. That'll probably be a pretty popular way to solve by graphing, is using the graphing calculator. We need y to be all by itself, so it is. I have like a habit of putting all fractions in parentheses, and I won't lie, sometimes you have to and sometimes you don't. If things start looking weird, I would put the fractions in parentheses. We'll type those guys in. And do you remember hitting zoom 6 to go to the standard window? So zoom 6. And I'm looking for where those guys intersect each other at. If they don't intersect on screen, I'll have to change my window. But here we're fortunate. So remember doing intersections, you hit second calculate. It's right above the trace button. Second calculate. And we're looking for choice 5, which is the intersection. So if I hit 5, it asks you a couple questions. It's like, hey, who are the 2 curves you want to hit to intersect? So when it probes you with that question of first curve, all you have to do is hit enter. Second curve, hit enter. And since there's only one place of intersection, your guess doesn't even matter. Like, we'll do that when there's more than one place. So I'm going to hit guess, and it showed up at 4, -4. So on homework, this is literally like a homework question. It's like multiple choice. Was there one solution, no solutions, or infinite solutions? There was one solution, so you'd select A, and it was at 4, -4. Is that where it was at? 4, -4. What would it look like if there was no solutions? What would the graph have? What would be true about those lines? They'd be parallel. And if there's infinite solutions, they'd be right on top of each other. And we got to give this fancy schmancy answer, but we'll get into there when we get there. So that was solved by graphing. The next way is solving by substitution. When to do it? Number 1, when the instructions tell you to. Or number 2, if you got a choice. Do you see how this equation right here has a variable like all by itself on one side of the equal sign? Like, we're used to elimination where like x's are on top of each other, y's are on top of each other, equals on top of each other, and constants. When you got a variable all by itself on one side of the equal sign, here's how I roll. I always teach it the same, be it if you're in Algebra 1 or college algebra. I literally like put a box around what x equals. I'm not going to force you to do that. That's just how I roll. And then I'm going to go put a parentheses for whatever letter was all by itself. And the rule is, take what's in the box and put it in parentheses, man. If you just substitute in, the parentheses definitely matter. So I'm taking what's in the box, and I'll put it in the parentheses. So I'm literally copying the bottom equation down, this guy right here. Exact same thing, but where there was parentheses, I put 5y plus 12. Then I'll distribute the 3 through. And then watch yourself, dog. These y's are on the same side of the equal sign, so you combine them together because they're on the same side. And then I'll subtract that 36 over. And, well, that's a 19. I was like, that's not going to come out very nice. Sometimes they don't come out nice, but I would say 99% of the time on these questions, they should come out to be nice integer numbers. So y equals -2, is that right? That's half your answer, right? A lot of people stop there, but we're looking for the ordered pair where they intersect at. So we're going to substitute back in, and this is where substitution is a benefit because you can literally just put this back into the box. Like you have x all by itself up in the other equation. So I don't care if you show work or don't show work. You can do it all in your calculator on that part. It's just putting -2 in for y, so that's -10 plus 12 more. Isn't that the deuce in that case? So x would equal 2. And be careful how homework wants it. They usually want you to write it as an ordered pair. So remember, x comes first, right? X comes first. Long time ago when you first learned to do this, you thought you had to get y by itself to do these. You do not have to have y by itself. You have to have a variable all by itself. So we had x all by itself. So I will let you and the neighbor do that on the next one. So there's the box, and it needs to go into parentheses. Your option if you want to do that. There will be test questions that say solve by substitution. So I have substitute in, and now I'll distribute a -3 plus 30 and 20 is 54. Is that right? Plus 54 right there. And adding those together on the same side is -13x. Subtract the 54 over, and I'm in good shape. X should equal 4. And then you can sub that bad boy back in. And y turned out to be 20 minus 18, which is 2. Cool. I want to preview before we go to the next. How come I didn't get no solutions? How come I didn't get infinite solutions? How did I know I was going to get one solution? When I substituted in and I got down to here, were there either x's or y's, I don't care what letter, was there a letter still left in there? If the letters go away, you know, like if you was to add up like, oh, 2x minus 2x equals 7, you know, and it's like, okay, that's 0 equals 7. When you get down there, the letters are gone. It's either no solutions or infinite solutions. So how do you tell? Does 0 equal 7? Yes or no? Nope, so that's no solutions in that case. So here's the ones we're more familiar with. And yes, there's 3 of them because I'm not trying to insult your intelligence. I'll bet after one you feel good with it. But I want to go through the no solutions, that one solution, and the infinite solution. So there's one of each in each one of these guys. So here's what you're looking for to do elimination. X's on top of x's, y's on top of y's, equals on top of equals, and constants on top of constants. Let's find a variable to eliminate. Wouldn't it be much easier to cancel the y's in that case? Since this is a 6y, what would you like the top guy to be? Minus 6y. What would you need to take this top homeboy times to get him to be a minus 6y? 2. Then I suggest bringing it down here. I'm not going to change your ways at this late in your algebra game, but I just show you how I organize. I also lightly strike that guy out to realize I am done with him. And now let's add those pups up. 13x equals -13. I'm going to stop right there and tell you I know I'm getting one solution back. Are there still x's or y's when I got to this point after I have eliminated? So there's going to be one solution. Divide x equals -1. What sucks about elimination is finding the other variable. You always got to like substitute back in. It helps me give you partial credit if we make a mistake if you show me where you substituted it back in. So I always like draw an arrow. It's like, yo, dude, I'm going to put -1 in for this x. It just helps me do that. So I would have -5 plus 6y equals 13. In my opinion, I think you should show work on this because there's some moves you got to do. So the more work you show, the more partial credit I'll give you on that scenario. But that's all she wrote. That's the old classic basic dude. Might want to pay attention on this next guy. Couple of whammies on it. They want us to do elimination. He's not ready. Why isn't he ready for elimination? Not lined up. I don't have x's on top of each other. I don't have y's on top of each other, etc. So here's my equal sign. I'm going to keep that there. Talk to me about this 4x. Do I want to keep him on that side, or do I want to move him? Move him. So you know how to do that. Wouldn't that be a minus 4x? So I'm going to put him right where he belongs. And I kind of like cross him out and say, dude, I've used you. Right? Talk to me about this 6y. Is he on the correct side or incorrect side of the equal sign already? He's good, so he's not changing. He's a positive 6y. Like I didn't need to move him over to the other side. And doesn't this minus 12 need to go over to the right side? Like he's on the incorrect side, so he would go over there to become a positive 12. So now I'm really going to get rid of that guy. I don't like him at all. So me likey that one. Who do you want to cancel? It doesn't matter. To me, I would do the x's because they have smaller numbers involved, like 10s and 4s are smaller than 6s and 15s, right? So who could I turn them into? What's like the least common multiple between 10 and 4? 20s, right? You know, so I'll take the top boy times 2. And I'm going to just kind of start. Sometimes I go to the right, but I don't have enough room, so I'm going to just start a new little system down here. And then I really don't want the bottom one to turn out to be 20. I need him to be negative 20, you know what I mean, because the top one was 20. So don't I just need to take him times 5, because he's like already negative. So negative 20x plus 30y equals 60. Makes sense what it did to do that. And then you notice it happens. We canceled our x's, but don't our y's also cancel. That instantly tells me I'm either going to get no solutions or infinite solutions. One of those options is happening. It depends on what I get over here. I get 0. Yes or no? Does 0 equal 0? Yes. So that is infinite solutions. And you may remember this. It was probably new last year. We got to do in the form of. Because here's what just happened. Don't want to bore you to death. You graphed a line, boom, you graphed another line. They lied right on top of each other. Even though there are infinite solutions, here's a question. Is that a solution to the system? Nope. Is this a solution to the system? Nope. There's an infinite number of wrong answers also. The solutions to the system are all these blue dots. Every one of these blue dots is a solution to the system. They're on the line. So what we need to do is take one of these equations and solve him for y. Let's figure out what y equals. So I will take this bad boy. I'm kind of running out of space over here, so I'll do it right here. I'm going to add 4x over. So are you kind of okay with that? I don't want to go too fast because this is where people are like, hey, what are you doing? I'm solving one of these for y. Now I'm going to divide everything by 6. So 4/6 is really 2/3. Sorry, my pen freaked out right there. Right there. And here's the answer that your homework will take. Here's the answer that the test will take. You told me that there were infinite solutions, so we'll write it out. Please spell it correctly also. Infinite. Every vowel is an I except for the last letter. There's an E. Infinite solutions. No, you can't put this because this symbol means infinity, which is different than infinite, right? Infinity and infinite are a little bit different. Infinite solutions in the form. And your homework's going to say, hey, could you put it in terms of x? So that means you're going to write a little ordered pair. The ordered pair always goes x comma blank. You really don't put a blank there. You need to fill in the blank with what y equals. Because isn't that how ordered pairs go? X comma y. Do we know what y equals? We sure do. Y equals 2/3 x plus 2. So you don't put the, you don't put the literal y equals. You just put 2/3, if I could write, plus 2. So x comma y. Your homework on some of the questions is going to ask, hey, solve this system. If you get infinite solutions, put it in terms of x. So that means all you put is this ordered pair right here. You don't have to write the sentence out. You put x comma 2/3 x plus 2. Let me help you with that on homework if you need it. Okay? Could you and a neighbor please solve number 7? Or if you're in video land, pause the video and see if you can solve that system by elimination. Biggest whoops is sign errors. Sometimes you didn't even make one of them negative, one of them positive. So I canceled the x's to turn them into 12s and negative 12s. Those gone, and actually so are the y's. They all add up to be nothing. So I'm either going to get one solution, no solutions or infinite solutions. This adds up to be -5. Now you may have not got -5 depending on if you did the top one times 2, or the top one times like -3 and the bottom one. So you might have got 0 equals 5. You might have got something different. The question is, whatever you got, yes or no, does 0 equal that number over there? No. So that is no solutions, which is my favorite one of these because that's the least amount of work you got to do, right? You do not put like in the form of or anything like that. There's no solutions. Those lines are parallel if you graph them. Yeah. All right, let's do some story problems. Would you please read this story, and then we'll figure out what X is all about. Asking yourself what X is. X is the number of bracelets. R is revenue. That's money coming in. C is cost. That's money spent, right? They ask where they break even. What's true if you're breaking even with the money coming in and the money going out? It is equal, it is equal, right? The money coming in and the money going out is equal. This is literally solving a system, right? I want to know where revenue equals cost, where R equals C. What you do is you set those bad boys equal to each other, right? Set them equal to each other, and it's kind of nasty little decimals. Solve for X. So I will let you do that. Subtract the 2350X over, and then divide by the 66.25, right? Does that come out nice? Yeah. It's not likely to come out nice, though. It doesn't have to. In this case, it did. It was 18 bracelets, right? But what if you got like 16.3 or something like that? That means you'd have to sell 17 bracelets. You always got to like round it up in that situation. So if it doesn't come out nice, that can happen, right? But hey, they might even say solve this by graphing. I highly suggest that you don't solve that by graphing. Like even with a graphic calculator, you know what kind of struggle bus it is to find a window to graph that in? Because the y-intercept is 1092.50. By the time you found the right window, you could have solved it with algebra, So like that's why I did it with algebra. Cool. So, all right, here's a tricky one. Give it a read on number 9. They want to know, in what year did Navy reach Air Force? AKA when they are the same. So how about we set them equal to each other, right? And what some ugly decimals these guys are, right? So we will set the Navy equal to the Air Force, and we'll solve for X. But man, it's watch how you're writing it down. It's a lot of weird decimals. So you can have different moves than me. One way or another, we'll get down to the same answer. I added this dude over. Then I'm going to subtract and get down to like this. So I'll punch that in and divide it out, and it don't come out nice, right? And if you get worried about that, that is a normal feeling. It's like, it didn't come out nice. They're not all going to come out nice. Keep that number in your calculator, though. Don't clear it out. X is about 27.16-ish, right? But that's not the answer to the question. X stands for years after 1960. I'm going to ask, because I see what part B is. Instead of adding 1960 to this in my calculator and like losing that number, I'm going to just see if I can do that mentally. Can I add basically 27 and the decimal to 1960? What would that turn out to be? 27 years after 1960 is 1987, right? 0.2, right? Or whatever, right? Doesn't that still mean you're still in 1987, right? Like 1987.0 is January 1st, right? 1987.2 is probably like mid-February-ish, So you're still in 1987. So I would say in 1987 is the answer to that question. But why didn't I want to clear that nasty decimal out? Because part B is asking me something. How many were in each service when the numbers were equal? Don't I need to put this number in for X into one of those equations up there? So because he's a nasty boy, I'm just going to do this. I'll pick the Navy one, right, the first one. It's -5.686. I hope that your math teachers in the past have showed you how to use the previous answer so you don't have to type that thing back in. It's right above your negative symbol that says ANS. So if you use the previous answer button, then you don't have to type that guy back in. And then what is it, plus that weird 676 0.173. Please see. The reason why I didn't want to round that guy off is because, one, my homework program is probably picky about if I used a rounded number like 27.2 and put it back in the formula, it's probably not going to equate the same thing. So we'll do that. And many people will type in 521.8 or whatnot, or maybe even 522, and it'll say wrong because this is tricky. Read back up there and see what is tricky about this guy. What made this tricky is this guy is in thousands. So you can either move this decimal 3 places to the right if you want, or just literally take it times 1,000, and there is your answer, 521,787. I just rounded to the nearest human being. So about 500,000 plus in 1987 in either force, the Navy or the, according to that formula. Don't know if that's really true. Whew, that was a long one. That was all linear systems. There's 4 questions left. I want to do 3 of them, but they are all non-linear. Are you down with the fact that you see a squared in there? You see a squared in here. If you look down below, you see a cubed in there. You can totally do them by algebra if you want. I do not suggest that. I suggest solve by graphing in your graphing calculator. Only one flaw. You got to get y all by itself to be able to do that. So let's do that with our first guy right there. We will get y all by itself. So here's this dude with the y in it. Doesn't the x squared and the minus x have to come over? So it will be a minus x squared and a plus x over there. Can we just take 3 over? You can. Yeah, that's fine. It works the other way too. Yeah. So 3y over. The question was, can you take 3y over? Yes, you can. One way or another, we'll get the same thing because I'm just going to divide by a -3. So -1 divided by a -3 is a positive 1/3. And then you'll have a minus 1/3 x on that guy. Then you got to solve the other guy for y. And let's punch both of those dudes in your calculator and see where they intersect. Use a little bit of your math common sense. I hope you know the blue one is a line, and the green one is what shape? Starts with P. Parabola, right? It's a parabola. So if you don't see those shapes, you may have made a typo punching them in. All right, so we'll put those dudes in my graphic calculator. It doesn't matter which one's y1 and which one's y2. Got those dudes in there. So zoom 6 to see if I see where they intersect. Whew, maybe not. We'll see on that top guy up there. It's kind of there. I might have to change my window. We'll see. But I'm going to do second, calculate, choice 5, first curve, enter, second curve. Now my guess is important because there's 2 different places of intersection. So whichever one my cursor is closest to is what it's going to find. So I'll go find that guy right there. -2, 2 is one of the ordered. Well, I'm in the wrong question here. My bad. -2, 2 is this one. Let's see if I can find the other one. I might have to extend my window up. So I got to do the process all over again. Second, calculate. Choice 5 for intersect. Hit enter for the first curve, enter for the second curve. But I got to move my cursor way over here. It doesn't have to be literally on top of it, but it's got to be closer to that point of intersection than the first one. So did it find it? Yes, it did, because it's at 610. If it was at like 611, you'd have to change your window. It's not going to calculate it if it's not on screen. So 610 was the other one. When they ask you to type it in homework, you might have to put a comma in between those. You might not. You just got to read how they want you to type it in. It's like type 2 ordered pairs separated by commas, or maybe they've got just 2 different answer blanks and stuff like that. So read how they want you to do it. That was a non-linear system. I solved by graphing. We'll do that again on this guy. I love that y is all by itself right there, and this is an easy move to get y all by itself. So why don't you graph those 2 dudes? Please make sure you type it in right. I kind of double check, did I type that guy in right? One thing that people accidentally do is right here, I'm going to change it. They have this, and they're like, it didn't work. And I'm like, yeah, that's because you have a subtraction sign in front of that x. It shouldn't be a subtraction sign. It has to be a negative sign. So watch out how you type it in. So I'm going to hit zoom 6 again, and see if I see what I want to see. That is awesome. I found the two places. Please use second calculate to find those intersection spots. One of them was at 2, 0, and I hope that you can get the other one to be at negative 2, 8. Did you get that? We'll solve those by graphing, right? I'm going to skip 12 because we don't have that on homework anymore, and that's a good thing. That makes a circle, by the way, if you was to graph that, so I don't want to deal with that anymore. But this dude, let's see where the struggle bus comes in. Y is all by itself on both of them. Why don't you punch them in and graph them, and let's see what happens. Got them all punched in. I'm going to hit zoom 6. It's kind of weird when you're doing it all in a black and white calculator. That's why I have a bunch of colored screen calculators. Sometimes that helps people see the things. But you see I got my blue snake and my red snake kind of thing going on. Find where they intersect for me. And then we'll see why it's wrong. So we found one of them at 4, 0. The other one's at 6, 0. You type it in and it says wrong. And do you know why? There's nothing wrong with that. But there are more. There are more places where this intersects. Would you believe that this red thing gets wider and wider and wider and wider, and this blue thing comes down, and somewhere down here they're also going to intersect? And you might ask yourself, how the heck were we supposed to know that? That's why I'm here, to help you with that. The easiest way you know is the homework says wrong, but you've done nothing wrong. So now maybe I'll show you a command on this calculator that you've never seen. Sometimes it works really nice, and sometimes it doesn't. Hit the zoom button for me, and we're not going to do zoom 6. But if you scroll down to zoom 0, does it say zoom fit? Do you see that? Sounds like a cool aerobics class. What are you doing tonight? Going to zoom fit, you know? But zoom fit sometimes works nice and sometimes doesn't. It tries its best to fit your graph on a good window. And can you see that other place of intersection way over yonder there? Now, we got this dude way out here, so I'm going to hit second calculate, choice 5, enter, enter, and move my cursor way over there. And there it was, at negative 6, negative 720. Can I give you advice, though, from doing this for 23 semesters? Don't hit zoom fit first. That's a bad move, because then people have a hard time seeing these two places of intersection. They're like, oh, I didn't even see there was 2 of them there. It's hard to tell with a red graph over a blue graph, but you get black and white, black on top of black. You can't see that there's 2 different points there, you know. So do zoom 6 first, standard window, find everything you can. If there's more, hit zoom fit. Cool?